Ford-Fulkerson maximum flow algorithm is a third method for today. First, we have to define the starting and ending node. So we define this is the starting and this is the ending node. Okay, we have to define what's known as a flow and capacity. So flow is currently at instant 0. There is 0 unit moving from S to A, but capacity of the line is 10. 0 unit from A to D, and capacity of the line is 9, as you could see here. So we have to maximize the capacity, the flowing, between S and T. So we need to find what's known as undirected paths from S to T, from starting to ending. Okay, so giving a graph which represent, I'm going to explain this like really briefly about the flow algorithm. Giving a graph which represent flow of network, where every edge has a capacity, as we said, is 10 here. We have the source S and the ending one here. Flow on an edge does not exceed the given capacity, which is normal, so cannot exceed this value. Okay, we have to start with an initial flow of 0, where there is an augmenting path. Augmenting is increasing from source to sink, which is like balloa. It is like the ending one and the line. We have to add 2 paths, flow to flow and return flow. Okay, in order to maximize the amount of unit going from here all the way to the end. As well as, so the terminology we're gonna use, we have always the residual capacity, remaining capacity, residual capacity, as you can see it here written, and residual graph and capacity. It is literally, if we flow 3 units here, so the remaining one will be 7. And then we have as minimal cut. Minimal cut is known as well as a bottleneck. Okay, أكتر شيء فينا نبعته على الخط, which literally would be, in a case we'll see in a bit, here will be maximum of 5. Even if this line can take up to 8, we could only send here 5. Okay, and let's see how this would work out. If we start, I'm gonna start with like an easier example. So we have, this is the starting, this is the ending here, and we have to obey by the direction of the arrows. So we have A, B, B, E, E, F, A, C, C, D, D, لا ماما لا حبيبي, D, F. Okay, and then we have A, C, C, B, B, E, and E, F. So we have to follow this direction, starting from A, ending to F. We have to obey by the sense of the direction, as you could see here. Okay, so let's take an example. All the capacity is written here. The flow is 0, as you could see here. Okay, the flow is 0, as you could see here. So in this example, which is like really easy and very straightforward, if we decide, well, to be honest, we cannot send more than 11 units at a time to F, and more than 15 units at a time cannot be sent out of from A. So the maximum flow here we have is 15 could be sent out of A, and the maximum to be received by F is 11. So let's see how does this one work. If we select, if we're gonna follow this line, so we have, so if you follow this line, so we start by A, and to see how does it work. Okay, so if we start by A going to C, and from C going to D, and from D going to F, so the maximum we could send here is 9, which is the minimum capacity on the line is 9. So the flow here would be, the maximum we could send here is 9, and so the flow here would be 9 and the flow here would be 9. The remaining capacity here, it's not 11 anymore, so it will be equal to 2, and the remaining capacity here equal to 2, and the remaining capacity here equal to 0. So no way on earth we could send more than this amount on this line. So the remaining capacity should be sent using different line. So if we send it, we do another line, A, for example, A, C, B, B, E, and E, F. So we could send here 0, and this one will be 8, and the remaining here is 7, and this one will be 8. Okay, so in this way we have sent all the unit as a maximum flow between A and F.